Good afternoon. Hello. Good afternoon. Hello, everybody. This afternoon, we have with us Professor Dorothee von Laer, representing the research team of his group in the University of Innsbruck in Austria. Professor von Laer is physician, specialist in microbiology and epidemiology of infection, and has been working during years in oncolytic viruses. Now, currently is professor and chair of virology in the Medical University of Innsbruck. It's a pleasure for me, on behalf of the Clinical Research Network VACCELERATE, for the coordination and conduct of COVID-19 vaccine trials, to invite Professor von Laer to present the preliminary results of the HeVACC study. This study is titled Heterologous Vaccination with Vaxzevria Prime and Comirnaty Boost compared with homolog vaccination with Vaxzevria Prime Boost or Comirnaty Prime Boost. At the end of the presentation, we will have time to talk for questions and answers, but during the presentation, your micros will be muted, but if you wish, you can forward your questions in the chat. Please, Professor von Laer, it's your turn.
Thank you very much for the introduction, and thank you for inviting me as a speaker in this really interesting group. As you have heard, I'm not really a coronavirologist, and also conducting large clinical trials. I've done some small ones in gene therapy, but not large clinical trials, also new to me. So, and also this is the first time we are publicly presenting the data. The study has now been submitted of our interim analysis of the HeVACC study. So, but before I start, I just would like to bring you the data from Austria, because you're all over, and probably, I don't know if anybody at all is from Austria online now. And these is our curves. We have the typical 4 waves. And at the moment, the numbers are really exploding. And so we can see here that we are at an incidence of around 280 at the moment at a weekly incidence, and for about 4,000 patients every year. We have every day new cases, and we have a population of 9 million people in Austria. And the problem is only 64% of the total population has been vaccinated, which is of course much too low. And we are dealing with a similar problem as Germany has, is that one of our major political parties is an anti-vaccine party, which is FPÖ, and they are like the AfD in Germany, and they are politically are very skeptical concerning all the corona stuff. And this, of course, then if the government is not in one line, then it's difficult for the people to really comply with the vaccination strategies. Okay, so as you probably all know, because you're all in the vaccine field, we've had a vaccine very fast for the COVID-19 disease, and we actually had several vaccines, and as we know, we have vector vaccines and mRNA vaccines, and especially for the vector vaccines, many studies in the past have shown, for instance, for MVA or for adenovirus, it's good for vector vaccines to generate heterologous vaccination schedules, because the boost with the second vector vaccine from the same type is usually weaker, and it is assumed that that is due to immune response to vector components that develop after the first injection. So there's very many heterologous vaccination strategies that have been studied, especially in animal models in the past, and it generally turned out that they were more potent than the homologous. In addition, we all know that the adenovector vaccine from AstraZeneca, the Vaxzevria vaccine, has the problem that it can cause rare coagulation disorders. So many countries have sort of stopped this vaccination in young women. And of course, then you have to give them a boost. And so the Comirnaty boost was given to these women, for example, in Germany, but without really any data showing that that would work, although a virologist would have predicted it. So several groups, not only ours, have initiated the spring trials to study if a heterologous vaccination with the AstraZeneca Vaxzevria followed by Comirnaty would be effective. We didn't do the other way around because it would have not been possible at that time to recruit anybody who received already the mRNA vaccine for a vector boost. That was actually virtually impossible because nobody wanted the AstraZeneca vaccine at that time. The primary objectives was to determine the immune response, whether that was stronger in or at least as good or ideally stronger in the heterologous regimen than in the homologous Vaxzevria approach. And the second was, of course, to show that it is that we have less breakthrough infections, but for that, of course, we will need much more individuals than I'm going to show you now for the interim analysis. And of course, we want to look at safety of the heterologous vaccinations. And if we have breakthrough infections, we want to study of course, the clinical course of these breakthrough infections for the different regimens. The primary endpoints are the level of neutralizing antibodies against wild type, but also against immune escape variants in the 3 study groups. And this will be done at days 10, 30, 90, and 180 post-boost. And in addition, we are studying the T-cell responses with several different assays to see where that level is. And as it is a secondary endpoint because we do not know if we will be able to vaccinate enough people in this study, but the occurrence of breakthrough infections, of course, especially with Delta or other immune escape variants, will be interesting to see if there's any adverse events or serious adverse events that are not expected. And we will study the clinical course, hospitalization, ICU, and outcome of COVID-19 disease in the breakthrough infections. We studied individuals over 18 and under 65. We recruited individuals that had been already vaccinated once, either with the Comirnaty, with the Pfizer vaccine, or with the Vaxzevria, with the AstraZeneca vaccine, according to the Austrian vaccination plan. And the participants that had been vaccinated with the AstraZeneca vaccine would have to have a vaccine of which is a maximum of 12 weeks before, and of the BioNTech 3 to 6 weeks before inclusion. Prior active infection or active infection with SARS-CoV-2 was excluded. We didn't have any patients that had participants that had been previously infected with the coronavirus. We had 3 study group, the homologous Vaxzevria group, which we termed AZ, will be in the all the slides, and a group which, the heterologous group, which received AstraZeneca followed by BioNTech, and 12 weeks apart. Both of these regimens were 12 weeks apart, and it was randomized and single-blinded, so the individuals were unblinded on day 90 post second vaccination. And then the open group, the homologous Comirnaty group, which had been vaccinated 3 to 6 weeks before inclusion into the trial. You don't have to read all this, it's clearly much too small, but you can see the different dates we had. So there was a lot of time points. People had to come a week before we would screen for basic health. So severely ill individuals were not included. And of course, the informed consent to exclude pregnant women, et cetera, Then on day 0, the vaccination was performed, and of course, the individual was followed up for half an hour to see if everything was okay. And during the first week, the individuals filled in electronic diary describing how their status was, if they had fever, rash, or anything, headaches, whatever. And on day 2, they also came in for a blood draw. And on day 10, also, they came in for a blood draw. The day 2 blood draw was only for toxicity parameters, and the day 10 was for toxicity and potential toxicity and for T and B cell antibody responses. Then we had, after 30, 60, and 180 days, we had again blood draws to study the immune responses, and the participants test themselves every week with an antigen test, and which they do quite nicely, report their results via electronically, and if they are positive, they're asked to immediately call us so we can take a swab in a proper virological medium and not in these lab media that kill the virus, which are, of course, a nightmare for every virologist. So then we analyze the virus, and we follow the clinical course closely of those that become infected despite the vaccination. We started recruitment on the 11th of May this year, and we're still recruiting, but I'm showing the data of the recruited individuals up to the 10th of July. And the data I will show include day 30 analysis of the last recruited individuals on July 10th. And I will present this data now in the following. The trial was as follows. We had screened 282 individuals by July and had to exclude 18, actually, because they had been previously infected without knowing it. We looked at anti-N antibodies during the screening 1 week before vaccination. And if somebody was anti-SARS-CoV-2 N protein antibody positive, they would be excluded. So 18 individuals did not know that they had been infected previously and could not participate. Then we had the priming with either vaccine. The BioNTech group was pretty small because we had started with the Vaxzevria group, and of these, the individuals were vaccinated. Some dropped out after vaccination, and then at day 30, there was a little over 100 in the 2 AstraZeneca groups, and 18 in the BioNTech group left to study. On day 10, where I will show data, we still had 28. Here's just the characteristics of the individuals that participate. They were on average not so old, but we will see if there's a broad spectrum of age. We have about equal numbers of females and males, almost always slightly more females. We now notice in our epidemiological studies also that females seem to be more ready to participate slightly. Body mass index comparable in the groups, and these are the intervals that were kept pretty closely between the first and the second dose. Here's just a picture showing male and female and total of the age. So you can see that in the different groups, it was pretty much comparable from the composition of the study groups. And we have a broad range of individuals throughout all age groups in the study, including also elderly. Actually, we did not see a stronger reactogenicity of the heterologous prime boost as has been described by other groups. The color coding will always be the same. It should be on the slide, sorry. AstraZeneca is blue, heterologous is purple, and BioNTech is Pfizer vaccine is red. So as you can see, all performed comparable. Of course, there was some general effects, but like for instance, not very many individuals had fever in this case, and it was mostly only on day 1 and not on the other days. So the vaccine was very well tolerated, and the heterologous vaccination regimen did not show any significant higher toxicity or reactogenicity than the other regimen. And here are the lab parameters we analyzed. You don't have to go through them all. They're like the basic parameters one likes to look at. And actually, they were all comparable between the 3 groups. There was nothing special about the heterologous group. And abnormal values in several patients were only seen for the D-dimer, that's because of the intramuscular injection, and for CRP as a sign of inflammation, which was generally high at day 2 post vaccination, or sign of inflammation, put it that way. Now coming to the immune responses. Here we can see the antibody responses as tested in ELISA with the arbitrary units, and internationally normalized arbitrary units, the BAU. And here we can see that in blue again, the AstraZeneca homologous group, and as expected, the BioNTech AstraZeneca heterologous group showing a higher immune response, antibody response, comparable to the response we see in on day 10 and 30 in the BioNTech homologous group. And here's also a historic control of a trial we did in spring of individuals at day 30 post BioNTech vaccination, which is also in a similar range. Also, the IgA titers were higher or lower in the Astra homologous group than in the other 2 groups. And when we look at the neutralizing antibodies, we can also see that these are higher, much higher in the heterologous group and in the Comirnaty group than in the AstraZeneca homologous group. And this is also true for neutralizing antibodies against the South African, the British, and the Delta variant, which is, of course, very important. We're still collecting here in the BioNTech group, but there is a slight tendency that Delta is neutralized even better in the heterologous group than in the homologous Pfizer group, but that will be seen when we have more individuals in this BioNTech Pfizer group. Then we looked at T-cell responses on day 10, and the T-cell responses is very, very clear. Here's interferon release to the S antigen peptide cocktail. Here 2 peptide cocktails. The assay is a commercial assay called quantiferon assay, which you can do in whole blood. And as we can clearly see, there's a significantly stronger T-cell response in the heterologous and in the Pfizer group than in the AstraZeneca homologous group. And this is also seen in the AIM test, which looks at activation of T cells in the VACCELERATE with different markers. And we can see clearly for the OX40, a stronger immune response, a significantly stronger immune response of the BioNTech containing groups relative to the AstraZeneca homologous groups, which is not, however, seen for 137 for the other marker. We then looked at intracellular cytokine staining, and also here there was a significantly stronger immune response, at least for the heterologous group versus the AstraZeneca group, not so prominent for the pure BioNTech group. This was true for gamma interferon TNF alpha, and also on the at the marginal level for IL-2, but also for granzyme B, for CD4. For CD8, we did not see significantly higher responses in the heterologous vaccination group relative to the other groups. But if we looked at the multifunctional T cells, we can see the lighter the color, the polyfunctional the T cells are. We can see that for CD4 and for CD8, there's a higher percentage of multifunctional T cells relative to the other groups. Interestingly, also better than the homologous BioNTech group. It looks like here the AstraZeneca BioNTech heterologous schedule may even be a little bit better than the Pfizer homologous schedule. We then looked at T cell responses to the immune escape variants. These immune escape variants are defined by antibody immune escape and not by T cell immune escape, but of course they also have T cell epitopes that differ. And here we work together with Daniela Weiskopf and Florian Krammer from the US that had peptide cocktails for the different variants. And again, we looked in the AIM assay, in the VACCELERATE AIM assay, and here we can see that for the different vaccination groups, here also the heterologous group has a higher activity than the AstraZeneca homologous group against the delta peptides for CD4 and for CD8 there we did not have enough samples, but it was also significant, this difference. And here we see a lot of other known virus variants, the P1 from Brazil, and these others are from California, stem the 1427, then South African, and the Alpha variant, the British variant. And here we also see that the AIM response is comparable to all the virus variants. So it is really only a T cell antibody immune escape, not a T cell immune escape seen in these variants, which others have also published, especially Daniela Weiskopf, with whom we cooperated on this. And again, also looking at the virus, the AIM response is stronger in the heterologous vaccination group relative to the homologous vaccination group for the CD4 and the CD8 T cells. We then looked at some other populations where we could not find differences. Those are the follicular T helper cells, which did not differ, that respond to spike, and also the immune response IL-10 and CD40 and IL-4 CD40 ligand did not differ between the different groups. And here below we see just the controls with a irrelevant virus as a control. And here we see that there was no difference in the T cell responses to CMV in the different vaccination groups. For the T cell responses, what I just showed you was all day 10. We then also did analysis on day 30. And here we still see a significantly higher quantiferon, that is gamma interferon release response in the heterologous versus the homologous AstraZeneca group. But the differences in the AIM assay have been nivellated. Actually, interestingly, here it looks like in the AIM test, the reactivity in the heterologous group has declined slightly, whether it has even further increased somewhat between day 10 and 30 in the AstraZeneca group, which of course is something one should look at more closely in future. Here's just the comparison between men and women, where we do not see any difference between the sexes in the antibody responses, nor in the T cell responses. So based on these results, we wrote an amendment to the protocol that was approved, and in this amendment, we then closed the AstraZeneca arm. This is, of course, something which we discussed a lot, because we're closing the arm which is treated with an approved drug or vaccine that many people are still getting, and we do not have any evidence that there will be a difference in protection. Although the responses will predict that there's a difference, but of course we do not have this knowledge yet. And but it was actually the fact that we could not recruit anybody anymore into the Astra arm because people just simply did not want to receive a second AstraZeneca vaccination. And so we unblinded this. From then on, everything went unblinded, and we're only studying further now heterologous versus BioNTech. We had 2 vaccine failures. Sorry, that slide is in German. 2 vaccine failures. A woman of 32 years old. She had day 75 after boost. She was in the heterologous group, and actually she had pretty good antibodies and also like an average T cell response. This is her here. Oh, sorry. I haven't shown this slide for the woman. It's only the man twice. That was a mistake of mine. She has a pretty average T cell response. This man has a low, but she was pretty much in the middle here with her T cell responses on day 30. She was infected by her child, who brought home the infection from kindergarten. I don't know if this child may have had a especially high viral load, but this was, of course, a very unexpected case. The second was not so unexpected. He had fairly low antibody titers on day 30, had a breakthrough on day 102. Here it's not clear where they are, and the T cell responses are low, and it's not clear where he became infected. Both had very light symptoms. They had mainly symptoms that were similar to a common cold, with upper respiratory tract, slight upper respiratory tract symptoms with running nose, etc. So that's it. Thank you very much for listening. These are the collaborators. So this is a collaboration between us and La Jolla Institute for Immunology and Icahn School of Medicine at Mount Sinai. And I want to point out the people who have large letters here. All of them contributed, of course, but Zoltan Banki and Jose Mateos were responsible for the T cell analysis, which was supervised and guided by Daniela Weiskopf. Annika Rösler set up and performed all the neutralizing assays, also with the virus. So for the neutralizing antibody screening, we actually used VSV pseudotype. But for the variants, we found that the pseudotypes did not correlate with the titers we generated with the viral isolates from the isolates. So all variants were tested with virus isolates of that variant in the P3 lab. And that was all the work of Annika, which she really did great. Florian Kammer was with me together. We both had the idea at the same time, and then I called him to do this in Austria, and then I called him, and we sort of started off together, and he supported us a lot with his experience. And Janine Kimper did all the operational leading. She's a group leader in my lab, and she really did all the hands-on work that have to be done to head a study, although I'm the MD and had to be the PI, and she's a biologist and could not be the official PI. She really was the central person where everything came together. And because she was so special, I have a photograph of Janine here at the end. So thank you very much.
Thank you very much, Professor von Laer, for your presentation. I think that we have now time for questions and answers. Please, Janina, help me if there is any order in intervention. For the moment, we have 2 questions already. I can read it. Rafael Cámara asks you about, he says, seeing that the heterologous vaccination is well tolerated and induce a better immunologic response like Astra, do you think that now there is a role for the use of Astra instead of Astra-BioNTech? In which or what cases? Well, you answered partly of that during your presentation.
So actually at the moment, although we do not have a long-term follow-up, the data very much support using the heterologous vaccine rather than the homologous vaccine, especially as people are not very, are sort of reluctant to receive the Astra vaccine, but I think one can convince them to do the heterologous prime boost, and there the Astra vaccine, which is there and available, and we have to use every vaccine we have to get people vaccinated. So there can be a very important market or place in vaccination programs of AstraZeneca as a prime.
Thank you. There is another question from Sabrina Abachi. She said, for how long will you be able to continue with trial?
Yeah, at the moment, recruitment is a bit difficult because people are not getting vaccinated in general. So only 1,000 individuals get vaccinated newly in Austria a day. So we will take 3 years until we're there where everybody else in Europe is to call out a Freedom Day. So it's going very slowly. We will try to continue to spring. Actually, we plan to do 1,000 individuals in each group. But at the moment, I'm not very optimistic that we will be able to get there.
Oh, thanks. Pierre Van Damme, sorry, I see something that you wrote in the chat, but not any questions and answers. Could you please, if you are interested in making your question?
Oh, there's also some more questions in the chat, actually.
So,
okay.
Which study group was unblinded? So blinded was the heterologous versus the AstraZeneca homologous group. Those two did not know what they got because both had AstraZeneca as a first vaccination, and then they did not know which second vaccination they get. Of course, the pure BioNTech group was not blinded because they knew what they would get because they were BioNTech vaccinated, only received BioNTech as a second vaccination. On day 60, so 3 months after the second vaccination, the people were told which vaccine they got. The AstraZeneca primed individuals were told if they got AstraZeneca or Pfizer, and actually those that have low or very low antibody titer on day 90, which are many in the Astra group, are now offered in an amendment to receive a third vaccination with Pfizer, which we will also follow up.
Good. Any other questions?
What was the exact timing of the bleeding for the cellular immunity? You showed it, but I missed it. Okay, so first I showed day 10 data, and then I showed one slide with day 30 data. And the quantiferon assays were done, I don't know what you mean now with timing, but I'll answer both possibilities. The quantiferon data were, the assays were performed within 6 hours after drawing the blood. And for the other assays, purified mononuclear cells were frozen and analyzed later.
Good.
Sorry, the second vaccine case, the second breakthrough case with a low immune response was the Astra group.
Astra. Good.
Sorry, yeah.
Okay. Any other question? Dr. von Laer, you see, we have been doing a not similar, but with similar results in our study COMBI-VASC. We are now analyzing the data for day 30 and day 90, and we have found a decline also in humoral immunity and in a neutralizing activity between the 25%, around the 25% between day 14 and day 30. These data are close similar to yours. We still are analyzing the activity in day 90, and we find that our data are more decay, more than double of the decay than in the first month, but we are still having, at least at the first month, a good activity in terms of neutralizing activity. I think that it must be clear for everybody that probably the best way to continue the vaccination schedules is mixing and making heterologous regimens.
Yes, I think it will, it looks at least good. And now I think it will be interesting to see if the stability is different between a homologous MR vaccine and a heterologous. So one argument I said for what would prefer AstraZeneca heterologous versus homologous Pfizer is not, the immune response at the moment is not much stronger, but is of course that we have to use every vaccine we have, and if we have to use Astra, then we use it in a heterologous regimen ideally. But the second argument could be, which I would predict, which we do not have data for at the moment, but which could be the case, that the heterologous vaccination may be a bit stabler than we've seen for the Pfizer vaccination over time. So that's an interesting question. I think now everybody will chase who is performing these trials.
Okay. Any other questions? No? Well, thank you very much, everybody. Thank you very much, Professor von Laer. I think that this has been a very pleasant afternoon, and we have the opportunity to learn a first-hand data and about this interesting experience. My opinion, we have to have many more of these meetings and these seminars, because the pandemic is, in my opinion, too long, but for the moment, I think that it is far from ending. So I think that we have to continue doing clinical trials, getting experience, and share our experience between people who are working in this area. Thank you very much to everybody.
Thank you.
Thank you very much to both of you. It was a pleasure to have you on our webinar.
Have a nice day. Bye-bye.
Bye.
Bye. Thank you very much.